Okay, so welcome everyone. This presentation is being recorded and um, I just opened up the wrong slide. There we go. So today's presentation is being recorded. So if you want to keep your camera and your microphone off, that is totally fine. There will be a chance after the presentations to ask questions and to engage with our speakers. So if you're comfortable at that point, you could turn your mic and camera back on, or you can always throw your questions into the chat box, and our committee will be monitoring the chat box as well. This is the 10th gathering of our Alberta Citizen Science Community of Practice, and we are a kind of a small but mighty committee that is hoping to provide a lot of information about all topics related to citizen science, and we thought today would be very topical given the current drought situation in Alberta. So, of course, our members are scattered across the province, and our committee is really scattered across the province, and so we want to start with a land acknowledgement and recognize that Alberta resides in Treaty 6, 7, and 8, and portions of Treaties 4 and 10. And Alberta also resides in the 5 territories of the Métis Nation of Alberta. We want to acknowledge that the land and water and air that we're all here for, we're all here because we appreciate and love the environment. We want to recognize that that has been stewarded by Indigenous people for centuries. And in this community of practice, we want to be inclusive of Indigenous people as well as their traditional ways of knowing. And we want to really value not only environmental data, but also all of our relationship to the natural world. So we have featured a couple webinars ago now, projects that are really being led, run by Indigenous folks who are using and weaving traditional knowledge with Western science. And so we really look forward to showcasing more of that in the future here. If this is your first meeting with the Alberta Citizen Science Community of Practice, then welcome. We are online at CitSciAlberta.com. We have lots of great resources there, but we are also currently developing an online collaboration hub, and we're hoping to launch that, at least get some feedback on that this fall. So stay tuned. We are going to have a very nice, fancy new website, and I hope you'll all find it really useful and provide us feedback as we roll that out. Our committee is somewhat informal, but we have representation from the Government of Alberta, from the Edmonton Area Land Trust, from Nature Alberta, from the Bow River Watershed Alliance, from the Alberta Lake Management Society, which is myself. And we're always looking for more representation as well. So if there is someone in the audience today who's thinking, hey, I think I could contribute to this committee, then please reach out. We would be really happy to hear from you. I perhaps should have introduced myself. My name is Brad, and I am the Executive Director of the Alberta Lake Management Society, and I'm also the current chair of the Alberta Citizen Science Community of Practice. I'm really excited that we are hosting an in-person event this fall. So the way this is going to work is we're running a webinar series called Webinar Wednesdays. This is really being spearheaded by our friend Catherine and fellow committee member at the Battle River Watershed. And so we'll have a series of webinars that culminate in an in-person workshop on October 30th in person in Edmonton. So this is your first kind of official save the date for that event. This is being sponsored through financial support from the Government of Alberta, but also the City of Edmonton. So you can see here some of the topics we'll be exploring, including diverse applications of citizen science worldwide, the value of engaging volunteers, innovation, including transformative tools, and place-based partnerships. The in-person workshop is really going to be focused on citizen science and policy, monitoring to drive change. So I hope you'll all take a minute now and throw that date in your calendar, and then stay tuned for more information as we build out the agenda and the plans for the webinars and workshop. If you want to stay engaged with us, this is some of the ways you can reach us on Instagram, on Facebook, on Slack, and you can also email us at info@citscialberta.com. All of our events get posted frequently on these platforms, and thanks to Kristen and Zoe, who really keep us up to date on those areas. So when you did register for the workshop, we asked you a bit about your affiliation, and this is what we heard. We had about 90 registrations for today's event, mostly from government, which is interesting. A lot of not-for-profit, which I'm not surprised by, because we do have a lot of citizen science activities within Alberta's not-for-profit sector, and so great to see representation there. And I'm also really excited about the folks who are citizen science volunteers or even fall within the other category. So if you do fall within the other category, maybe let us know in the chat what your affiliation is and why you're interested in today's event. Within those affiliations, we most frequently at our meetings see a lot of representation from the water sector, but very happy to see biodiversity and climate and air. Air has been a focus of previous webinars as well. So happy to see a couple folks there. And then again, representation from others. So if you are in one of those categories and you're on the call today, do let us know in the chat where your primary focus is. Okay, so the plan for today is to have presentations on two different topics. So we'll have Masaki, Hayashi, and Wendell Koning presenting first, and then we'll also hear from Grant Parkins. And we'll try and hold all of our questions until the very end. And Tracy from the Masaki Institute, I think I forgot to say Masaki earlier, but Masaki is one of our most critical partners. Tracy is helping to run our Q&A with these speakers, so she'll lead you through that following both presentations. Of course, if you have a burning question, throw it in the chat so you don't forget it during these presentations. We'll try to wrap up by 1:30 today. But with that, I think I'll invite our first speakers. So our first speakers are Masaki Hayashi and Wendell Koning. Masaki is a professor in Earth, Energy, and the Environment at the University of Calgary. And Wendell is a retired limnologist with more than 20 years experience in water quality. And as it seems retired limnologists do, they stay very active in this field. And so Wendell is also the co-chair of the science committee at the Bow River Basin Council, and also a director on the Alberta Lake Management Society. So my boss, so welcome to both of you, and we're going to hear about community-based groundwater monitoring. So I will stop sharing my slides and they'll invite either Wendell or Masaki to share your presentations.
Okay, well, thank you, Bradley, for introducing us. I'm Masaki Hayashi from the University of Calgary. Today I'm going to talk about this community-based groundwater monitoring that we started nearly 20 years ago, not quite, in the county of Rocky View. So I would like to tell you about, why we want even to monitor groundwater. So starting with, okay, let's see. So in Rocky View County, these are primarily agricultural communities. So many houses have water wells. So they have these traditional users of water. And then in the past several decades, there are a lot of residential development in the county. So a farmer would sell his 160 acres. All of a sudden, there will be 40 houses, new houses built with 40 wells. And then Also, there are some industrial activities such as hydrofracturing for the oil and gas development. So there was a concern as to, well, if do we have enough water? So that was kind of motivation for studying this project nearly 2 decades ago. Now, so these are the water used by human, but then there are other users of water, which is aquatic ecosystem. So we need to look at the surface water and the groundwater connection. For example, pretty much all the rivers, including the Bow and Elbow River, starts from some headwater springs in the mountains. So this is all fed by groundwater discharge. And then there are groundwater feeding the rivers along the way. So this is a picture of a big hill spring north of Cochrane. And then there is this ecosystem that is dependent on groundwater. So this is West Nose Creek, just a few kilometers north of Calgary. So it's a dry prairie vegetation in the background and the foreground. But then this, creek side is wet because of the groundwater feeding this vegetation. And then not to mention all the insects and fish living in this water. So this connection of groundwater with surface water is very important. So when we talk about this connection, we talk about this cycle of groundwater through recharge and discharge. For example, this is one of the springs in the Glenbow Ranch Provincial Park. So the water is trickling down this little creek because there's a spring upstream somewhere. So the groundwater is discharging to the headwater of this creek and supporting all the ecosystem here. And then discharge needs to come from somewhere else. So that's the recharge. So there's some farmlands on the upland areas of the watershed. So that's, providing groundwater recharge. And so that's added to the groundwater system, and then it provides this discharge supporting the groundwater dependent ecosystem. And then there are some wells in the watershed pumping well from the same groundwater system. And then typical size of this system is about 100 meters deep, and then maybe 10, at most 50 kilometers. So this is appropriate cycle, or this is a cycle, the scale needed to understand the groundwater in the context of groundwater management and environmental management. So again, going back to this, the connection between recharge and discharge. So there's some farmlands, groundwater is added to the system by recharge. So that's the input of groundwater to the system. And then there's an output of groundwater, providing this input to the streams. And then there's some wells pumping water for various uses. And then if the input, which is recharge, exceeds output, which is discharge to the stream and the springs and also pumping. And then there will be an increase in storage. The water level will go up. But if the discharge and pumping exceeds recharge, and then storage will go down. So it shows up as water level going down. But in the long term, if you look at 20, 30-year average, typically the recharge and the pumping is balanced by discharge. So this is a kind of healthy way how the groundwater system should operate. But if we overpump the groundwater system, so that might cause the large drawdown of groundwater level. Some of the existing wells may go dry or decline in water level, or there will be a reduction of base flow to the stream. So in extreme cases, the stream might dry out, or the springs fed by groundwater might dry out. So really, the sustainable management of groundwater needs to avoid these things that's written in the red font. So to achieve this, we need to be able to monitor the groundwater storage, change of groundwater, and also the base flow as well. So when we look at the groundwater monitoring wells run by the government, so we call it the GOWN wells, an acronym. So there are many GOWN wells, but it's a large province. For example, this map area encompassing Rocky View County and several other counties, there are 27 wells in this map area, but map area is 70 square kilometers. So one well per 2,600 square kilometers. That's really not a large enough density to monitor the condition of groundwater at the scale of a small watershed. And then many of these wells were installed for specific purposes in the past. So, for example, the industry will install wells for monitoring purposes. Then they'll hand it down to government for the monitoring wells. So that had happened in the past. So there may not be suitable for local watershed monitoring. So government of Alberta have added a lot of new wells for the purpose of watershed monitoring, but that's not all the wells. So we do need more wells for the high density monitoring of groundwater. So we started out a small pilot project around 2004, 2005, and then extended it to the entire county of Rocky View around 2007, 2008. So it's called Rocky View Well Watch. So these are all farm wells monitored by the citizen scientists for keeping eyes on the groundwater. So currently it's hosted by the University of Saskatchewan's Global Water Future Networks database. You can go to this website and look at the data. I'll do the live demo in a few minutes. So here's a methodology we used. So first, we worked with the Rocky View counties. Back in those days, there was a person named the agricultural field man. Yeah, I don't think that position exists anymore, but basically it's a person who liaisons the county with the farming communities. So it was really important for us to contact the farmers through this agricultural field man. Tim Dietzler was the name of the person. Some of may know Tim from many years ago. And then we got the well owners to volunteer their wells, but then we just couldn't take any wells. The wells need to be suitable for the long-term monitoring of the baseline condition. So we looked at the location of wells, the depth of wells, and the length of the screen, and then selected 40 or so wells that are suitable for the long-term monitoring purposes. And then for each of the wells, we sampled water, analyzed them for the chemistry and the bacteria, just to ensure that our operation, meaning that involving them for monitoring their wells, did not cause additional bacterial contamination on top of what was already there. So we got them to follow the standard protocol for the disinfection of water level sander by bleach solutions, because you might actually contaminate wells by bacteria if you use a probe that is not disinfected. And then we ask them to stick this probe into the well. When this needle touch water, it beeps, so it gives you the water level. So we asked them to monitor or the measure water levels in their wells as frequently as possible. Bi-weekly, every 2 weeks is desirable, but every 2 months or once a year is also better than nothing. So I'll just show you the how the database looks like now by just exiting this slideshow mode now. Sorry, go to this. So this is our Rocky View Well Watch database accessed through the University of Saskatchewan's database. So each point indicates farm wells monitored by volunteers or monitored by the pressure transducers that were installed by us. So for example, this one here, so this is monitored by a acreage owner. Going back to 2008, you see the patterns of water level going up. So that indicates recharge. And then water level goes down because of the discharge to the streams and maybe some pumping as well. So you can kind of see the seasonal pattern, also the interannual patterns. And then this one is still carrying the impacts of drought. So there's no recharge for 2 years. And then this last point is late May. No recharge has happened yet. But if you look at another well, not too far, For example, this one here. This is also monitored by an acreage owner frequently. So now this one has started to respond to recharge by the spring melt this year. So it's a good sign that this year might be a turning point, getting out of the drought. So going back to the slideshow here. Now, so you can look at the spatial distribution of the water levels. So I've just kind of lumped them into three groups. The northeastern part of the Rocky View County, so this will be Calgary, the white zone in the middle, northwest and southwest. So all these wells show the interannual pattern. So 2012, 13, 14, 15, we had wet weather. So most of the wells had a recharge, so the water level went up. But then there was a dry period, 3 or 4 years of drought period. And then there are a couple of good years and then another drought. So the water levels were declining all wells. So this stops in the end of December 2023, but some of these wells actually have already started showing the sign of recharge. So this is a way we can keep eyes on the groundwater system by engaging citizen scientists. So another look at this. Okay, so there's a West Nose Creek watershed. It's a small watershed, about 250 kilometers squared north of Calgary. And then there is one of these monitoring wells, well number 325. So this is a typical hydrograph of West Nose Creek. So the amount of flow in the creek. So there are some heavy storms, typically in June. So the creek might be flowing bank full. But often the creek is just at the base flow condition. It's a trickle of water like this. So in the next slide, I'll show you the base flow measured in the fall in this West Nose Creek. Going back to 1980s. So this was monitored by Water Survey of Canada. And then this gauging station was cut by Paul Martin in mid-1990s. And then we at the University of Calgary installed the gauging station in the same location and started monitoring again. So you see that the base flow has some variability from year to year. So some wet years, so a pretty good base flow, and then dry year. Last year was not very good, a very low base flow condition. But luckily, it never dried up. And then, so this is the water level in well 325 from Rocky View Well Watch. So you see a strong correlation between the water level, groundwater level in the aquifer, and the base flow in the West Nose Creek. So this is a demonstration that groundwater and the creek are intimately connected. So we need to keep eyes on the groundwater levels, and we need to manage groundwater and the surface water together in an integrated manner. So another interesting thing is that this past 20 or so years actually had a good base flow compared to decades earlier. So this is the same location measured using the same method. So this difference is real. So, and then the question is why it's so different, 1980s versus last 20 years. So this graph is called the standard precipitation index. So this shows the deviation of rain and snow from average condition. So red indicates drought and blue indicates deluge. So the last 20 or so years, we had a wet period, about 10 years, and then followed by another 10 or so years of dry period. So that is reflected in the groundwater level and creek base flow as well. And then 80s and 90s were generally dry. That's why we had such a small amount of base flow in the creek. So we expect that the groundwater levels in the wells in Rocky View County were probably lower back in the 80s and 90s compared to how it is now. So, okay, so the next few minutes I will spend describing, it's not easy to maintain the community-based groundwater monitoring network using citizen science approach. So, some acreage owners and farmers may have been very enthusiastic supporting this network, but then the interest kind of wears off. So the most challenging part of this groundwater monitoring network is to keep the volunteers motivated by getting them interested. So this shows a few years after it started. So there's still about 40 left, but it went from these numbers to that number in the years following. So we did a survey of volunteers back in 2012. And so what do we need to do to keep them motivated? So some volunteers said, well, the access to wells, these are in their yard. It's difficult in the winter when you have 2 feet of snow. So that resulted in low data frequency. But they also said, they want to know what the data means. So we're doing all this work to support your network. So what do we get, as a feedback? So we started setting up the website called the Groundwater Connections. So this is a place where they can find the information about local groundwater. We even involved grade 8 teachers to develop the curriculum for the schools. And then I send out the newsletters to all volunteers every year, typically in January or February, to tell them what we found from the data collected that year. So that keep them interested and motivated. So as a result, so this year, this is the current number, we still got over 20 wells left in the monitoring network after nearly 20 years of operation. So just to wrap up my part of the talk, so this community-based local network of groundwater monitoring is necessary to keep eyes on the groundwater and surface water condition at a watershed scale. And the community-based approach offers an effective alternative to government-run monitoring. So they are complementary. So engagement of volunteers through outreach and education is a key to the success of such program. And then with this, we can extend it to a wider region within the Bow River Basin. And these are just acknowledgement for the organization and people who have helped us. And with that, I'll pass it over to Wendell so he can tell us about how Bow River Basin Council is planning to extend this network to a wider region. Okay, so I'll stop sharing now.
Thanks, Masaki. Yeah, so Wendell, we can help you share your screen there if you need a hand.
Am I sharing?
Not yet. We don't see your screen just yet.
Okay, let me check here.
Okay, something's popping up for me now. Okay, and then if you go into presenter mode.
How's that?
Okay. That looks really good, Wendell. Take it away.
Great. Okay. Thank you. So I'm just following up on Masaki's presentation. I've got a short presentation, about 5 minutes, just to identify what we've been doing in the Bow River Basin. So what we're trying to do, as it says on the screen, extension into the broader Bow River Basin. So we're following up with what Masaki has been doing in the Rocky View County, and we'd like to spread it over the other parts of the Bow River Basin. So we've been going since about September 2022, so now we're into 2024. We haven't started any field project yet, but we're getting closer. We got a great groundwater subcommittee, and you can see the members there, a variety of people from consultants to people in retired nonprofits. Dr. Nilo, she's with the Masaki's Institute, and she actually initiated this. She was able to get funds through TD Canada Trust, Friends of the Environment, $10,000. And with that, then we decided, okay, well, we have to do something with the money. And so we started a committee, and you can see the technical advisors. There's Masaki, Kathy, Peter Elkes, and Lisa. They're on the call as well, I think. And Jean Burks is one of our advisors, and she's with on the call as well with the Government of Alberta. Then we have Brook Capeller involved. So again, what we're trying to do is to extend the geographic range of what Masaki has started. So here you see then we've got Rocky View County surrounding the city of Calgary, and then you got the Bow River here. You got the Red Deer up above, and South Saskatchewan, the Old Man, and so we've got plenty of area that we can grow the program. We're probably going to move more first into Bighorn. The MD of Bighorn and Foothills County down here. Here you got the Ghost River and the town of Exshaw. Foothills, we've got Fish Creek, and then of course some of the other rivers as well, the Sheep Highway, Wheatland, New Well. There's a lot of areas we can expand into. Steps along the way, we're starting with working with prospective landowners. We've developed a fact sheet. We've got a questionnaire for interested owners. Alberta Drillers Reports, I'll look at that in a moment. We have an MOU waiver form that needs to be completed by all people involved, and that includes the landowners, BRBC, and the University of Calgary. And as we saw from Masaki's presentation, having contact with the individual counties themselves, with the ag field people or others, is really helpful. But it takes a lot of time just to set this up properly, and especially if you hope to do this for a couple of years or 20 or 30 years. So this is the fact sheet, and thanks to Mike Weldon on our committee for putting this together. Fact sheet, a 2-pager, just on the involvement up to date in groundwater monitoring in the Bow Basin, working with citizen scientists, with volunteers. Bit of background on groundwater 101. Here are the techniques used for groundwater monitoring. Data collection methods. Alan Brakey, he's one of our members. This is some of the data from his well in close to Calgary. We have a questionnaire that we send out as well, and this is for the Ghost Watershed Alliance in the MD of Bighorn. Again, just the name of the landowner, the year the well was drilled, approximate depth, distance to water, diameter, the type of aquifer, and on, just so that we have some information. And at the top of page 2, it does say that we also need a driller's report. And so this is what a driller's report looks like. It's a water well drilling reports. You can find these online. It's all publicly available, but you have to know what to look for and the name of the individual, the original owner, when the water well was drilled. And so this gives a ton of information, which you really need. Here, the lithology of the well, and the borehole information on that, the surface casing, what kind of casing, the type of seal, the screen type, and then on page 2 as well, more on the yield test, the type of pump, and on. So this gives a lot of information. And Dan Brown, one of our members, was saying too, you need those Alberta drillers reports, to ensure that the well is properly constructed and the producing zone is sealed off from other data. You want to make sure you're working with good quality wells that aren't leaking, that will give you good advice year after year after year, decade after decade. Another slide here, just on what we've bought so far. So what can $10,000 buy you? Well, we bought $8,000 of material so far. So here we've got these 10 electronic water level meters. We've bought 10 of those. We've bought a couple of pressure transducers that you can put in, and they continuously record. And we bought a barrel logger as well, which is great. And notice down here we've got Peter Elkis, and so we're storing this equipment at SAIT. We needed a place to store it, a safe place, convenient, where it'll be accessible to people if and when needed. So that's great. We appreciate that Peter and SAIT have been able to provide that. So the final slide then, just on the current status. So we're working with, we have about 5 are expressing interest in participating. One response so far from Upper Fish Creek, another one from Lac des Arcs. And so with these, we're trying to we're trying to find the drillers' reports that then we can proceed further with interacting with them and very likely working with them to install our first monitoring sites. So we expect this summer and fall, that we'll be working on 6-12 sites, and then we'll continue to build in 2025. Most of us are kind of volunteering. Many of us, many on the committee are working full time, and so we can only do so much at a time, and we want to do this well, and so we're the setup has taken us a bit of time, and then the goal, as we've said, and what Masaki has been doing, multi-year and in fact multi-decade, and so we're looking forward to proceeding with this, and I think it's great that Citizen Science Alberta is interested in this and helps us spread the word. And also this way we can find out from others what they're doing and have some meaningful interaction. So I'll quit with that and I will pass it back. I'll stop sharing my screen. So
great.
Thank you.
Yeah, thank you, Wendell and Masaki, for those presentations. I think groundwater is often out of sight, out of mind for people, and so really interesting that base flow in the one creek at least is driven so much by groundwater. So maybe we will pause for questions right now, and we'll save those to the end. And for now, we'll invite Grant Parkins to provide his presentation. And Grant Parkins is the Watershed Education Coordinator for the Center for Public Engagement at the University of North Carolina. Did I get that right, Grant? Okay.
The Center for Public Engagement with Science.
With Science,
yes.
At the University of North Carolina. Really, your title should just be like the cool satellite guy, because Grant does really interesting work using satellite imagery and monitoring lake levels, and have been happy to be able to collaborate a bit with Grant over the years, and really appreciate you joining us today to share a bit about your work. So I'll invite you to share your screen and take it away from there.
Great. Right, I'm hoping.
Yeah, I'll let you know if
sharing now.
We're not in presenter view. There we go. Yep, that looks really good.
Great. Well, thank you. As Brad said, my name is Grant Parkins, and I work for the University of North Carolina at Chapel Hill. In the southeastern United States, I work for the Institute for the Environment, and I'm going to talk with you a little bit today about a project that I work on called Lake Observations by Citizen Scientists and Satellites. Specifically talking about how we combine citizen science with satellite data to monitor lake levels. So essentially what we do is we are looking to better understand how the volume of water in lakes is changing over time. And we do that by combining data from satellites. Primarily, it could be either satellites measuring how the boundaries of the lake edge change, so the surface area changes. It could also be how the elevation of the lake surface changes, so the water levels rising and falling. But we combine that satellite data with data about lake levels that are provided to us from citizen scientists on the ground in lakes around the world. And we use that to determine, when you combine those two pieces of data, we can use that to determine how the volume of water in lakes is changing over time. And so I want to talk with you a little bit about three of the questions that we're asking with this project. And so one is we have asked and answered, can citizen scientists provide accurate lake height measurements? And I'll talk to you about how we went into that. We want to know if lake volume is change within a region is driven by local or regional factors. And then we also want to know, can citizen science be used to validate nadir altimetry data? That's data from satellites for small and medium lakes. So our project began in 2017 with a pilot project here in North Carolina, here in the United States. We have currently expanded to a total of 10 different countries on 4 continents. And so we are studying lakes really around the world, including right there in Alberta. And since we began in 2017, we've had more than 8,500 citizen scientists involved in the project. We have more than 67,000 lake height measurements, and we're studying 272 lakes. Now, some of the citizen scientists that are involved come by and are able to submit one measurement, and that's great. And others will submit measurements repeatedly over a long period of time. And our most dedicated citizen scientist has actually submitted 928 lake height measurements. So we've got some really great folks that we get a chance to work with. As I said, we are studying lakes in Alberta. We're currently studying 11 lakes in Alberta, and this is a map, mostly near Edmonton, but we are looking to expand soon. So I want to give you an example of what we have done there in Alberta, and so this is Walter Lake in the Elk Island National Park. And this is a gauge that we installed in the lake in the forefront there, where volunteers or just people passing by can read the water level. It's measured in centimeters, and then they can send us a message from that. The little floating raft in the background with an antenna is actually, we took surface elevations for all of the lakes as well. But when I say we installed a gauge or we're working with citizen scientists, usually what it means is they are reading a gauge similar to this. So how does it work? So what we'll do is we'll work with a local partner and citizen scientists to install a simple gauge like you see there on the left, somewhere in the water, ideally accessible to the general public, and close enough to the shoreline that people can read it. And on top of every gauge, we install a sign similar to what you see here on the right. Now, every lake has a unique 4-digit code. This one happens to be THW2. And in every region, we actually have a local phone number. So this example that I've got here is actually from the Seattle, Washington area, and that's a Seattle phone number. But our phone numbers there in Alberta are you would recognize the area code as being from Edmonton. So we install those where people can come by and see them. And what they will do is they will follow the instructions on the sign to send a text message to the number on the sign with the 4-digit code, the lake level as it's read on the gauge, and then if they want to include any notes. And once they send that off, we have partners at Tennessee Tech, computer scientists that have worked out a way to receive those text messages, plug them into our database, and respond immediately with when the last recorded lake height was and what that lake height was. And so nearly instantaneously, what will happen is our website will show the measurement that the citizen scientist just submitted. So this is an example of the website for that particular page. For that particular lake. Every lake that we study has its own particular website that people can view the data in real time. So that's how we get our lake height measurements. We get measurements from satellites as well. Specifically, we're now using a satellite called SWOT, or Surface Water and Ocean Topography satellite. This is the world's first comprehensive study of water resources from space. And this satellite launched in 2022, and it is collaboration between space agencies in the United States, Canada, France, and the United Kingdom. And what is happening is that satellite is passing overhead and surveying the entire surface of the Earth. including the surface water, and it's hitting just about everywhere at least once every 20 days. Now, the closer you get to the poles, more of those paths overlap, and so there we have several lakes that are measured more than once every 20 days because it falls under two paths. What we do is we send out emails to remind our citizen scientist volunteers that tomorrow is a day when the satellite is passing overhead. So what they'll do is they'll get us a lake height measurement on the same day we get a lake surface area measurement from the satellites, and that's how we can combine the data, the lake height data with the surface area data, to see how the volume of water has changed over time. So one of the things that we asked early on in the project was that we felt like we needed to show folks was that we needed to see how accurate citizen scientists can be when they're submitting these lake height measurements. So what we did is we installed these pressure transducers, Solon's level loggers, in some of our lakes early on in the project. We set them to record a lake level every 15 minutes to 60 minutes. And depending on the lake, it was in the lake either between 2 and 9 months. Once we did that, then we can compare the citizen scientist measurement from that lake with the level logger measurement that was the same, that was taken at about the same time. And what we found is that citizen scientists are submitting accurate lake height measurements. So this graph here on your right, let me kind of walk you through it. Every one of these points represents a paired measurement, meaning that this is the citizen scientist measurement and the level logger measurement taken at the same time. You might notice from the bottom left to the top right, there's a blue line. The closer the dot is to the blue line, the closer the citizen scientist measurement was to the level loggers measurement. So what that tells us is just by looking at this, you can see that citizen scientists are very accurately telling us what the lake height is. In fact, we found that the mean absolute error of citizen scientists is only about 1.6 centimeters, which compares very favorably to the level logger itself, which has an error of up to 0.8 centimeters. So we feel really good about how accurate we're getting, how accurate the measurements are that we're getting. And I should also say we did this analysis with more than 2,700 lake height measurements from citizen scientists in the states of Washington, North Carolina, and Illinois. So what are some of the things that we've learned about our lakes? I will mention that the lakes in Alberta there, we just installed in gauges in August or September of 2022. So we haven't even had them in the water for 2 years yet. So it's a little early to start drawing conclusions from those lakes, but I thought what I could do is share some examples of what we've learned about lakes that we've been studying for a longer period of time to give you an idea of how, given the time, what we can learn about Alberta lakes. So a couple of the questions that we ask is, one, are lake volume changes for lakes within a region correlated? And then two, does the distance between lakes within a region play a role? So what we found, these are examples in North Carolina. What we have found is that there's mostly positive correlations between lake pairs in North Carolina. What that means is in the state that I live in, if we're studying two lakes, as the lake height of one increases, the lake height of the other one will increase as well. And you can kind of see these trends here of lake pairs. And so the blue line is one lake and the red line is the other, and you see they kind of mimic each other. So that's one of the things that we find in North Carolina. And we find that in many places as well. I'm just using this as an example. We also find that the strength of that correlation decreases as the distance between lake pairs increases. So what does that mean? If I have two lakes, for instance, in Illinois, and they're only separated by about 10 kilometers, we can expect that as one, the lake level of one is rising, the lake level of the other is rising. And if we look at the pattern over time, those patterns look very similar. But if we have two lakes that are, say, 80 kilometers apart, they might be going up and down at generally the same pattern, but it's not quite as paired as the ones that are closer. All of this seems to make sense, right? You would think that lakes that are closer together are rising and falling at about the same rate at the same times of year. But by comparing those two kind of conclusions together, what we can then determine is that within a region, the volume changes within a lake are on average significantly correlated. Meaning that if we're looking at a lake if we're looking at lakes within North Carolina or other regions, they're all going up and down at mostly the same pattern. But also in some regions, the distance between the two lakes predicts how strongly correlated they are. And so this suggests that there are both local factors and regional factors that are influencing the volume change. And so a regional factor might be what is the climate, how much rainfall are you getting, things like that. The local factors might be Lake A is highly developed around it, and so has a lot more runoff from the watershed, and Lake B is pretty remote, and although they're not very far apart, Lake B doesn't have nearly as much direct runoff into it. So those are just examples of what you can find by studying multiple lakes over a period of time within a region. Those are the same questions that we are asking about Alberta lakes as well. So I want to give one more example of a question that we're asking, and we are about to publish a paper on it. Can citizen science be used to validate nadir altimetry data? So nadir altimetry is, so imagine you've got a satellite passing overhead, and it measures the surface of the land or the water directly below it. So it measures a very small area on the Earth, but a couple of existing satellites that have been around for a while that do this are satellites called JASON-2, JASON-3, and Sentinel-3. And scientists have measured the accuracy of nadir altimetry over large lakes and found that they're very, greater than, say, 100 square kilometers. And they found that this nadir altimetry can be used for lakes that are that large. However, there's a whole lot of lakes that are smaller than that, and we don't really know how effective this method is for measuring small lakes. And so what we've done is we've looked at 27 lakes that are smaller than 100 square kilometers to see how accurate this method is for measuring lake height changes. And one of the lakes that we were able to use, because as I said, this nadir altimetry measures such a very small portion of the surface of the Earth. One of the lakes that we're actually able to use is Half Moon Lake, which is just east of Edmonton, and it's a relatively small lake. So to give you an example, this red line represents roughly where the nadir altimeter for Sentinel-3A measures. And so it's measuring a swath of Half Moon Lake there. And so we use that in our analysis to see how well these satellites are measuring small to medium lakes. So our takeaways, specifically about Half Moon Lake, we found that Sentinel-3A did a reasonably good job of measuring changes in Half Moon Lake. And in fact, of the lakes that we studied that were smaller than 20 square kilometers, Half Moon Lake was more accurately measured than all of the others. And so we could say that, we could actually use that particular satellite data to get a reasonably good idea of what's happening with the water levels in Half Moon Lake. We also found that satellite measurements are most accurate when lake levels don't change too dramatically. And again, we're talking about in small and medium lakes. And so if you have a huge difference between high and low every year, or the water is rapidly rising or rapidly falling, the satellite measurements become less accurate. And I'll say this, all of this work, I posted it there at the bottom of my slide. My colleague, Angelica Gomez from here at UNC, is spearheading this particular analysis, and she has a paper in review right now. But the key takeaway is that with some caveats, it should be possible to use modern nadir altimeters to directly observe water levels in small to medium lakes. And that is great news, because we've got all these satellites in space, and for a long time people thought they were only good for measuring really, really big lakes. But what we found is that actually these satellites can be used to measure many more lakes than we previously thought. And so we've been able to show how that can be done. I want to mention that we are moving into a new phase with our project right now, where we are switching to a new satellite, which is the Surface Water and Ocean Topography Mission, or SWOT satellite. I had mentioned it earlier. It launched in December of 2022. It's a collaboration between the space agencies in the United States, Canada, the UK, and France. And it is currently up there measuring variations in lake stage, lake levels, river discharge, and ocean circulation. And this particular satellite is we have lots of lakes all around the world that were on the ground, specifically set up to measure how accurate this satellite was. And we are in the process of analyzing that data so that we can, using citizen scientists' measurements on the ground and comparing it to what this satellite has measured. And we are, the initial returns are that it looks like it's really good, better than we could have expected and better than anything else available right now at measuring water from space. And that's true for both small lakes all the way up to very large lakes. This particular satellite measures both the surface area of the lake as well as the elevation of the lake. So it has a nadir altimeter as well. And so one of the questions that I get a lot is, and I thought I would just put it on here, was how will this help us understand a changing climate? And really, to understand any aspect of climate or climate change, we have to have data over a long period of time. But there's no comprehensive database of lake levels, and most lakes are not regularly monitored. There's probably 20 million lakes in the world that are larger in size than 10 hectares, and only a few thousand of those are monitored regularly. The LOX project has shown that both citizen science and remote sensing can be used to build these data sets over time, so that then we can understand how our lakes may be affected by a changing climate. I'll mention over there, the picture on the left there is, that's me on the right side. In the middle is Angelica Gomez, who I mentioned. And on the left is a community partner of ours in Kenya named Gandhi. And this is actually one of our lakes in Kenya. But I wanted to mention Angelica because I just talked about her research. We are expanding our network of lakes. We're seeking partners and looking for new study lakes. Ideally, we're looking for natural lakes that are greater than 10 acres in size. Ideally, they would be publicly accessible. We put these in a lot of state parks and city parks, off of boat launches, things like that. But we do have some that are private, that are only accessible by private property, if that's the only way we can do it, and we can connect with a citizen scientist who is willing to put it there and monitor for us. So if you are interested, I'll have my information at the end, and you can please reach out if you think this is a good fit for a lake that you work at or oversee. I want to just acknowledge the LOX team. The PI on the project is Tamlin Pavelski, who's a hydrologist here at UNC Chapel Hill. Dr. Sheikh Ghafour from Tennessee Tech heads up the data science side of it and the computer science side. Dr. Faisal Hussein is an environmental engineer. He has been instrumental in helping us expand in Southeast Asia. And I also mentioned Angelica Gomez, who's a postdoc and helps out in lots of different aspects of the project. But that's all I have. I appreciate you all giving me the time, and I hope if I get invited back to these with one of these in the future, I can share actually up-to-date results about what we found out about lakes in Alberta. It's still a little too early yet, though. But thank you all.
Yeah, thank you so much, Grant. Very, very interesting work. I am blown away by the size of the budget I saw on that one slide. So congrats.
That was not our budget. I'm just going to put that out there. That was not our budget. That's NASA's budget. So
that makes more sense. Amazing. I'm going to invite Tracy, a fellow committee member from the Masaki Institute, to guide us through some Q&A. So Tracy, take it away.
Thank you so much, Brad. Both were wonderful presentations, and we've got a lot of questions, and I also have some questions. And I'm wondering if I can invite Masaki and Wendell to put their cameras back on, and we will start off. I think we'll go back to Masaki and Wendell. One of the first questions was that this is, the longevity. People are very impressed with the longevity of this project. It's a wonderful example of citizen science. And could you talk maybe about the partners, Masaki, that have to be involved in something like this?
Okay, yeah, thank you. I'll take a stab at this. Well, first and foremost, the involvement of Rocky View County was very important in the beginning. And then there are several watershed conservation societies, such as the Nose Creek Watershed Partnership. So those gave us basically the initial push to get this started. But the really longevity owes to the people who kept measuring water levels every month and then entering them to the database. And then I guess, as I said in the slide, the key is to keep them interested because otherwise, they stop, getting interested. And then this, the groundwater is something that's really core to their life. It's the lifeline for them. So for them, it's really, important and interesting to keep eyes on the groundwater. So that might be the key to the longevity.
Great, thank you. Thank you so much. Now, Grant, we have a couple technical questions for you. Can you comment on if this methodology using the satellite data could be translated to measure river stages? And then a second follow-up is has there been work to correlate satellite gravity measurements with lake levels to calibrate groundwater gravity data? So if you can answer those two. The first one was on using satellite data to translate to measure river stages, please.
Sure. So first off, I will state the caveat that my individual expertise is not in remote sensing. The remote sensing piece is Angelica Gomez, who I mentioned, and Tamlin Pavelski. My expertise is community engagement, and so I work with the local partners to get on the ground stuff. All of the stuff, citizen science stuff, is more of my realm. But I think I can answer both of these questions. The question about can it be translated to measure river stages? The answer is yes. If the river is big enough, it has to be of a certain size to be able to measure changes in water height. I'll also say, it's happening every. We'll take the SWAT satellite, for instance. It's measuring pretty much the entire surface every 20 days. So you're not going to catch the flashiness that you'll get in rivers, right? So, but you could get, if the river is large enough, you could get overall trends over time. And then the other question was, can you repeat the part two?
Yes. Part two was, has there been any work to correlate satellite gravity measurements with lake levels to calibrate groundwater gravity data? I don't even know what that means, so maybe you could first explain what that question actually means.
So there may have been. I don't know of that. I don't know of any way that I don't know of any satellite that's being used to measure groundwater. In that way or any other way. Again, though, I will state that the remote sensing piece is not in my. I've picked up some stuff from Tamlin, the PI. So, however, anyone that I can has specific questions can send them to me, and I can send them to Tamlin, or you can research him. You do a Google search for him, Tamlin Pavelski, and he can answer those questions as well. But I would say the answer is no to that one based on my knowledge.
Okay, thank you so much.
Yeah, I can jump in here. So the person's talking about gray satellite data. So that's a gravity measurement, and then they're having an effort to back out the groundwater storage change from the GRACE satellite. But this GRACE satellite has a footprint much bigger than the stuff Grant was talking about. We're talking about 500-600 kilometer. So will probably difficult to correlate the changes in gravity with the altimetry data that Grant is using.
Thank you very much. Okay, Masaki, we're back with another technical question for you. This is from Sherry, and she's wondering if you found your research could find a correlation with low snowpack, and if there's any direct impacts near oil and gas drilling that has been started in the areas you tracked. Could you comment on that?
Yeah, on the first question, definitely yes. So it's get a bit involved, but groundwater recharge in Alberta is primarily happening underneath those little sloughs. So if you don't fill up the sloughs with snow melt, there will be no recharge. So there's definitely a strong correlation between snowpack and how it's melting and recharge. And on the second question with the fracking, that's a contentious issue. So one of the original goals of setting up this program is to establish the baseline data. The baseline has these ups and downs due to the changes in the weather and the snow melt and whatnot. But if you do that for several decades, and then you'll be able to pick out anything that's out of ordinary compared to the natural ups and downs. And then we did see a few. Just all of a sudden, the water level keeps going down with no correlation to the meteorological factors. So that's due to pumping nearby. But I don't really know if that was caused by fracking or some acreage owners pumping, 24 hours, 7 days a week or something like that. But it is able to detect those things once you do the long-term monitoring.
Okay, thank you. Grant, we're jumping back to you, and we're wondering how you achieved such a global distribution for your project. And the second follow-up is, there's actually two follow-ups because one's for me. Have you been able to collaborate with local managers, decision makers? And then I guess my question would be, is the data accessible to people in Alberta? So how did you achieve the global distribution for your project is the first part of the question. Yeah,
so some of that is a combination of building on partnerships that we already have. And so Faisal Hussein from the University of Washington was already doing citizen science work with people in Southeast Asia, and so we were able to connect with those in that way. Our Tamlin Pavelski has folks in France that he reached out to get some lakes in the Pyrenees. So everything from that to cold calling, for lack of a better term, we got to Kenya because a gentleman in Kenya who was interested in it found our website and reached out to me, and we made it work. I have spoken at different conferences and things that have gotten folks to pique their interest, and they've reached out to me. But early on it was a lot of, we want to go to this location. Let's see if we can find citizen scientists or lake monitoring programs or things like that in that area, and it was sending emails and phone calls and things like that.
Nice.
So I'll answer, and then you asked.
Yeah, I wanted to know if you how people in Alberta would access the results or the findings.
So locks.org, LOCSS.org. I'll post it in the is our website, and you'll be able to find the data there. We're working with we're working on two things right now. One, we're working on how to automate the satellite data and put it on the website. That's one piece. The other thing is we're working with the website guy to make it so that you can basically just push a button and download all the data into a CSV file. In the meantime, you can reach out to me and I can send you all the lake levels for those. So all of that's available. And then was there two follow-ups?
I also asked just how if you're connected in with land managers or collaborators and land managers in areas locally.
Yes. So it looks different in different places, and so actually in Alberta we got connected by Caleb, who was at Alms, and he connected us with the national park and some other folks and some citizen scientists who are already doing it, and so that's what it could look like. In some places we connect directly with the citizen scientists or the lake management group or whatever for that one specific lake. It depends on the location, really.
There's a lot of flexibility in the program, Grant.
There is, and I'll say one of the benefits of it is that putting a gauge in the water is cheap, and so that's part of the reason why we've done this, and we've set up the infrastructure to be able to receive text messages and automate that process, and that's how we can end up with 65,000 measurements that are texted in into a database. So.
Thank you. I want to kind of switch tracks here and talk a little bit about the use of this information. And so, Masaki, you mentioned that, this can supplement an existing Government of Alberta wells monitoring program that they have established, but you mentioned the density. This is increasing the density in the Rocky View County area. Is there coordination or sharing of information back and forth with the province? And if so, how might they use this information?
Well, not particularly at the moment, but the fact that there are several of folks from Alberta government in charge of their ground monitoring network on this call might mean that there might be an avenue to actually integrate the information some way. But this is a kind of two different quality because government, they need to ensure the accuracy on everything, whereas a citizen science project, well, accuracy is important, but it's not that we can guarantee the accuracy, right? So there has to be some ways those two things can be somehow merged. But I'm hopeful that there will be continued conversation with the government of Alberta.
And then likewise, Wendell, the BRBC is expanding this program, obviously, because they see great value in it. And can I just ask how you plan to use the information you collect, or what it is informing? You're on mute, Wendell.
I think it's a way to engage the local citizens in the different watersheds to become more active in managing their landscape. And so with more knowledge, people are inclined to do so. So a lot of it is just for informing landowners and making them feel empowered that, yes, they too can be part of, managing their watershed, envisioning their watershed and what they want and perhaps what they don't want. So I think that's key. And then again, like Masaki was saying, it can be used to augment data collected by some of the provincial monitoring agencies, and whether it's the exact accuracy is needs to be discussed, of course, and it's not the same as the government data, but it still has the more you can work with the landowners to ensure that the best possible data gathering possible, the more it can be used in by the various land managers, including those at the provincial level.
Great, thanks, Wendell. Grant, I'm back with my two-part questions for you.
Okay.
The first is, do you have a sense of how many people who actually walk by one of your devices actually makes a report? And the second is, I wanted you to comment, which something you said in your presentation, which is really seems to be common with citizen science project, is that you can generate a lot of interest, which is great for education, but it tends to be a small group that really drives data collection. And so I just want you to comment on those two things if you can. So the first, again, was about how many people would actually stop and engage with the device and make a report.
Yeah, so we don't, there's, the short answer to that is, I don't know. There's no way we can tell. An example, we have a gauge and a lake at a very, very popular park in Seattle. And in the summertime, we might get 8 measurements a day, but there could have been 50 people that walk through.
Right.
There are other places in much more remote things, we might not get anything, once every 3 weeks. So there's really no way of telling. Now to your other part, it's been a while since I've actually broken down the numbers, but a year or so ago, I looked at what we found is that roughly 80% of the people who submitted measurements via text message, 80% of them did it one time and one time only. But something like, I'm sorry, about 2/3 did it one time and one time only, but something like 80% of our measurements came from people who submitted 10 or more measurements, right? So we're getting, so it's a combination of people who are just passing by and doing it once, and that's great. We're engaging with them, even if it's very briefly, but that's actually a really great recruiting tool, because people will then get the message back and go look at the website and decide they want to participate more. And so both of those kind of groups are very important to us in getting the data that we use to analyze this. So.
Great, thank you. And I have a question that any of you could answer. It's around technology. I noticed in both of your presentations, you talked about, in particular in the groundwater well one, about the importance of engaging or continue to motivate volunteers. And I noticed that there's just what technology has enabled you to do in the instantness of the reporting that you guys are doing. And I just wondered if you could comment about technological innovation and the role you think it's played in your projects.
Okay, I'll go first. Yeah, the monitoring is low tech. I think it's just a tape measure with a little sensor that beeps when it touches water. So in that case, not much on that side, but then I think data dissemination, that we went through several phases. So first we relied on the commercial operation, and we failed because we were not generating enough income for them. So eventually we switched to the academic institution, not as slick as commercial, but it's reliable and then understand the purpose of this long-term monitoring. So that was a kind of a bit of technological bit I can tell you about.
Thank you. No one else has to comment, but if anyone else does have a comment, now is the time.
I just think that you know, I mean, the feedback when it comes to the program that Masaki's been involved in now and what we're trying to do, I think the feedback loop, you know, and the technology, the ability to communicate easily with the local landowners and keep them motivated and provide them with interpretive materials, you know, on a frequent basis is critical to the success of having something that goes multi-year. So I think the new technology, or just, you know, really accessing all that technology that's out there for, you know, communicating with the landowners and then probably with the local counties as well, with their ag field people and the land managers is really, really important and exciting.
And I'll just add that we also use pretty simple technology. SMS or text is simple technology. However, it's not widely used in certain parts of the world, and so it's really important for us to meet our citizen scientists where they are. Folks in Kenya or Colombia or Chile would prefer to use WhatsApp because that's what they use. The same thing with getting information back to them, the indigenous communities that we work with in Colombia. We are specifically creating kind of a newsletter style thing and getting it to their the kind of leader of the community that they can share. So you know, I think when you're working with different communities of people, we can't force them to use. We may see them as quite simple. Just go to our website and read our blog. That's not going to work for everybody. So the best thing to do is understand what those communities want and need and try to meet them there. Try to do that for them.
Thank you so much. Grant, there's a few more questions for you. Can you just speak a little bit about the volunteer monitoring and database, how you can sustain the volunteer monitoring and database over time? So what kind of funding and supports are required for a global project like yours?
Yeah, so we're currently on the second 3-year grant that was offered by NASA. And each of those have been about $1.5 million, but that's paid for us to expand and everything else. That funding will be done in about 1.5 years, but we have very strong indication that we can continue to get funding, perhaps not from NASA, who funds us now, but because there is no single one-stop shop to get this information, even though many lakes and lake managers around the world are actually measuring it, we think that perhaps the next phase of our project is to get money to be that spot that people can share their data with us. It's there for everybody. We can train them on how to install a gauge of their own, use our infrastructure, but doesn't require me to fly there and install a gauge. So we're thinking about lots of different ways. I work for a university, an institute of the university, and one, you know, everything from fundraising with individual donors to sustain the project, all the way up to obviously grant writing.
Great, thank you for that. Okay, Wendell and Masaki, this is a big question for you. Any broad thoughts around how we might bring greater attention to groundwater in Alberta?
Go ahead, Masaki, you first.
To bring more attention to groundwater in Alberta? Well, you know, I do not feel that the groundwater is not getting enough attention in Alberta. I may be biased because I study groundwater, but I talk to the farmers and the acreage owners. They do understand the importance of groundwater, and my good colleagues at Alberta Environment and what was it called, the EPA. They seem really, you know, interested in both surface and the groundwater. Yeah, but it's an invisible results. So I think education might do a bit more, like a grade school level education that will probably raise the awareness a bit more on the younger generation. How about you, Wendell?
Yeah, well, I was going to say too, a drought is a big motivator. If you can connect groundwater to, our current drought conditions and how important groundwater is for that, then, people start to listen. And so there's a reason. I mean, if we're concerned about drought, and most people are, kind of scares them, especially younger people, perhaps, then letting them understand that groundwater is a big part of that picture. I think that's important. And I think we've been noticing the fact that we're super involved with this now in the BRBC. There's a reason for that. People are very interested right now. We just had an all-day science forum with the Bow River Basin Council, and in-person science forum, and a good half of the presentations, were related to groundwater and where the groundwater comes from, and did you know what's happening in our upper watershed? And so I think that now is a good time to. It's quite a popular topic right now. So I think we're just kind of riding the wave, and perhaps we can, as long as we continue in our communication, we can be part of that wave. It's a good time for those studying. I think Park Fontaine is on our line here, and a few other students. It's a good time for them to be studying groundwater and geoscience.
Okay, thank you for that. Thought that was going to stump you guys, but it did not at all. Grant, a few more questions for you. Have you had people tampering with your installed gauges? And how can you tell or make sure that they're not being tampered with?
So yes, we have people tampering with them. Usually it's just straight vandalism. Like, I don't think anybody's like going out and knocking it down 6 inches with a sledgehammer. But we have had gauges that have been shot up. They were out in national forests and they just got used as target practice. Usually we find out because one of the citizen scientists will include it in a message like, hey, the gauge seems off, or somebody ripped it off, or things like that. Or we show up to clean the gauge and whatever. So that happens. We also have to be careful about where we put the gauges. There are places we need to be careful of bears. Actually, I was told that I can't think of off the top of my head, but one of the gauges we put in one of the in the national park there, I believe it was there at Elk Island. The water levels have really receded, and now it's not in the water, and the bison have been using it as a scratching post. So we've had to locate things where hippos couldn't get to it, and locate things where bears or bison couldn't get to it. So those are all things that we have to figure out. What we've decided, though, is that we kind of take it on a case-by-case basis. The gauge that got all shot up, we never replaced the gauge. You could still read the water level below all of the bullet holes. And then one day I went out there, it so rarely got measurements. One day I went out there and it was gone, and we just decided it's probably not worth reinstalling here. So we do those things kind of on a case-by-case basis.
Thank you so much, you guys. I think Brad's popped back up because it's almost 1:30 and we're out of time. Brad, did you want to sign us off?
Sure, yeah. Thank you, Tracy, for leading us through that Q&A. I know that was all these questions for different speakers on different topics, so you did a great job keeping those straight in the chat, and thank you everyone for putting such thoughtful questions in the chat. What I wanted to do just before we close out is share with you this screen, which again is highlighting the workshop we'll be hosting in October in person in Edmonton. And that will be preceded by a number of webinars that we're really happy to bring you on kind of broader topics in citizen science, and from speakers from multiple jurisdictions who are going to share their experiences with us. So of course, I also want to thank our speakers today for putting those presentations together, for taking time to share your information with our audience, especially Grant, who's joining us from another time zone. Wendell is retired. We've got a professor, like we've got folks who are really, really generous with their time to share with us today. So I want to thank them, and I want to thank our audience for being such a great audience, and of course our committee and Tracy and all the folks in the background who were able to make today happen. So if you're not on our mailing list, again, please do check us out through any of these channels, and you can learn more about the work that we're doing here in Alberta. And with that, I think we'll go ahead and sign out. So thanks everyone for participating today.
Thank you.